Hello everyone, this is the Return to libc attack lab. We are given this source code with the main vulnerability in this source code is the buffer overflow. So we need to check out this file a little bit. Here the payload is read from the bash file and it will try to call the BOF function with that payload. The payload is 1000 bytes maximum. Now in this BOF function, the buffer size is only 12. So we can easily see that after it calls the string copy here, string copy from the pass-in string to the buffer inside the BOF function, it will override, it can override the return address of this function, and we can exploit that. And for this lab, the countermeasures are disabled right here. The address-based randomization is turned off using this command. And this will make the program run at the same address every time, and the libc will be linked into the same address as well. And this source code is compiled without any canary, and it will be compiled with no executable stack flag, which means we cannot put the shellcode in the stack and then execute the shellcode. And another thing to notice is that we need to make the symbolic link from this string bin/sh into the bin/zsh. Zsh is a shell that will not drop our privilege if we create that shell. Because normally if we use the system on the string bin/sh, it will call the dash shell, and dash shell will drop the privilege from set UID program. And our program is a set UID program. So first let's do this. Uh, okay. The vulnerable. So the first task that we will perform the attack is task number 3, launching the attack. Here we are given this script to exploit to generate the payload and save it in the bat file, and that bat file is the input for our program. Here's the example script, and we need to find out where the x, y, and z and the address of the string bin/sh and system function and the exit function. In this lab, we will put this string in the payload itself and use the buffer address to calculate the address of this string. Now, in order to find out the variable x, y, and z, we need to debug here a little bit. Here we will dissolve the function main. We can see that after we call the function BOF, then our return address will be this address. And let's take a look at the BOF function. Okay, in the BOF function, here we can override our return address with the string copy function right here. So we just need to set a breakpoint here and see where is the return address is on the stack and where is our buffer on the stack, and we can calculate from the start of our buffer to override the return address. Let's set breakpoint here. You can see that this function string copy will take 2 arguments. The first argument here and the second argument is here. This is the destination, so we will print out a few hex values from this address. This is the start of our buffer, and we can see that the return address that we mentioned earlier in the main function is here. So from this address until this first byte is 28 bytes. That is why this function, this value y here is 28 to override this return address with our system address. And after this BOF function return, then it will jump into the system function instead of returning to our main. And we need to put our exit function right above the system function, because after running the system function, our program will try to jump to the next function. So we need to put the exit function right there to make the program exit normally. Otherwise, it will be segmentation fault. For the bin slash hx string, I decide to put it at the end of our payload. So its address will be our buffer plus the length of our payload right here. So let's run it. Here we can see after we run the red lib with our new generated batch file, it generates a new shell for us right here. The next task is task number 4. This time we will try to defeat the countermeasure of the dash shell. Now we'll make the symbolic link from this string to the dash shell using this command. Okay. Now if we run the previous attack again, we will see that this time we will not be the root because the dash shell will drop our privilege and we will be the normal user, not the root user anymore. So to bypass this, we will use another function, is execv. If we try to call the bin slash hh with the p flag, then the created shell won't be dropped privilege and we will still be the root of that shell. So we can use the execv to pass in another argument is the b flag here, and the way to call it is mentioned in here. This is the instruction of the lab. So for task number 4, I have the script here, and it's quite straightforward. The address here is the x, y, and z are the same. The address here, we now use the execv function, so we replace the system address with the execv address. At the end, at the end of our payload, we will put the string bin/h and the flag p here, as well as constructing the array of argument to pass in, like mentioned in here. So that is simple. Here we can see that we now have the root permission again, and the program will exit normally. For the last task, this is based on the return-oriented programming attack. And this time it is much easier. It just requires us to invoke the full function 10 times before we execute our shell. So we just need to put the address of the full function 10 times in our payload, and then our original attack. Right here is the script for task number 5. We just need to put the address of the full function 10 times here, and the rest is pretty much the same. Okay, here we can see that the full function is invoked 10 times. We are still the root. So that's it for this return to libc lab.